Hello viewers, in this class we are going to see about how to design a FIR high pass filter using Fourier series method for a given frequency response of a filter. Here in this problem, the frequency response of the filter is given as HD of e power j omega is equal to 1 for the frequencies minus pi by 4 to pi, that is the magnitude value. For 0, the other frequencies. Find the value for h of n for the samples n is equal to 11, h of z, and the frequency response h of e power j omega. We have already seen what are the steps involved in designing the high pass filter, that is a FIR high pass filter. The step 1. Step 1 is plot the response from the given specification. That is, from this it is observed that from the question it is noticed that it is symmetrical about 0. That is e power 0 is equal to 1. So it is symmetrical about 0. The response is from minus pi to plus pi. Here the frequency response is greater than, that is the modulus value, minus pi by 4 and plus pi by 4 to pi. That is a greater than pi by 4 and less than pi, with a magnitude of 1. That is HD of e power j omega, greater than pi by 4, less than pi. And similarly for this, minus pi by 4. From this, from the plot, it is observed that it is an high pass filter. Okay, the cutoff frequency is greater than the pi by 4 and less than the pi. So for this response, for this filter, we are going to design a FIR filter. The step 2. So what is the step 2? You have to find the desired response. We identify the type of the filter. So from the plot, it is identified that it is an high pass filter. Step 2, find desired response. So you know the relation to find the desired response, that is HD of n is equal to, that is by using the Fourier series, 1 by 2 pi integral minus pi to plus pi 1, that is the HD of e power j omega value is 1, e power j omega n d omega. Okay, from the plot, the integral value is 1 by 2 pi minus pi to minus pi by 4 e power j omega n d omega, then plus 1 by 2 pi by 4 to pi e power j omega n d omega. Okay, next, solve the integral value. This equal to 1 by 2 pi, that is the integration of e power j omega n, that is e power j omega n divided by j n. The limit is minus pi by 4 and then minus pi, and similarly plus 1 by 2 pi e power j omega n by j n. The limit is from pi by 4. Apply the limit 1 by 2 pi, that is I am taking pi, that is I am taking n as in common outside, e power, that is omega, substitute the upper limit value, minus j pi by 4 n divided by, that is minus e power minus j pi n divided by 2 into j. I'm getting here. And similarly for this 1 by n pi e power j pi n minus e power j pi by 4 n divided by 2j. That is, I am taking 1 by n pi common outside, collecting the e power j pi n term, e power j pi n minus e power minus j pi n divided by 2j, and then here minus common outside, e power for this e power j pi by 4 n, and here minus, here plus, minus into minus plus, so minus e power minus j pi by 4 n divided by 2j. So you know that e power I theta minus e power minus I theta divided by 2 is equal to I sin theta. So and this one is equal to, this value is equal to sin n pi. Okay, that is sin n pi, that is 1 by n pi sin n pi minus sin n pi by 4. Okay, so hd of n is equal to sin n pi minus sin n pi by 4 divided by n pi. You can easily find the desired response from the plot itself. Very simple. The total response sin n pi, the total response sin n pi minus you don't have the signal from 0 to pi by 4, minus sin n pi by 4 divided by n pi. Okay, so we have found the desired response. hd of n is equal to sin n pi minus sin n pi by 4 divided by n pi. Next we are going to find the actual response. So you know the relation to find the actual response. H of n, that is step 3. Step 3 is to find the actual response. That is, the response, the n value is from minus infinity to plus infinity. We are truncating the infinite samples into finite samples. Here the number of samples n is equal to 11. So in your problem the value n is equal to 11. So n is equal to 0 to n minus 1 by 2. So n takes from 0, 1, that is 10, 11 minus 1, 10. 10 divided by 2, 5. 0, 1, 2, 3, 4 and 5. Okay. So from this, first find h of, you know that hd of n is equal to sin n pi minus sin n pi by 4 divided by n pi. Okay. First I am going to find h of 0. So 0 means 0 by 0. It is undefined. It is undefined. So I am applying the L'Hospital rule. There are two ways to find the value for n is equal to 0. That is applying the L'Hospital rule or applying the n value directly to the desired response in the integral form. From that you can easily find the value for h of 0. So I am going for an L'Hospital rule. That is, differentiate numerator and denominator separately, so that my relation will come as, that is h of n is equal to, differentiate with respect to n, so pi into cos n pi minus pi by 4 into cos n pi by 4 divided by pi. So for this I am going to apply it as a 0. For n is equal to 0, it is cos 0 value is 1. So pi minus pi by 4 divided by 5. So that is 1 minus 1 by 4 by pi, which is equal to 3 by 4. So the value for 3 by 4 is equal to 0.75. So h of 0 is equal to 0.75. So pi into 1 minus 1 by 4, 3 by 4, h of 0 is equal to 0.74. Similarly, you have to find the value for h of 1. So h of 1 is equal to, you know that sin n pi is equal to 0. That is, substitute the value for 1, sin pi minus sin, that is, sin n pi value is equal to 0. So that minus sin n pi by 4 divided by n pi. Substituting the value for 1, sin pi by 4 divided by pi, and this value is equal to, h of 1 is equal to minus 0.225. So keep it in mind, keep your calculator in radian mode. Okay, similarly find for h of 2. So h of 2 is equal to minus sin 2 into pi by 4 divided by 2 into pi. So this value is equal to minus 0.159. And similarly for h of 3, h of 3 is equal to minus sin 3 into pi by 4 divided by 3 into pi, and this value is equal to minus 0.075. And similarly for n is equal to 4. For n is equal to 4, that is h of 4 is equal to minus sin 4 into pi by 4 divided by 3 into pi, and this value is equal to, that is 4 by 4, sin pi value is equal to 0. And for h of 5 is equal to minus sin 5 into pi by 4 divided by, sorry, here it is 4 pi, that is 5 pi. So 5 into 4 pi, 5 into pi by 4 divided by sin 5 into pi by 4 divided by 5 pi, and this value is equal to, that's a positive value, 0.045. Okay, we have found the filter coefficient from for n value is equal to 0, 1, 2, 3, 4 and 5. Next, you have to find step 4. Step 4 is, you have to find the transfer function h of z, which is non-realizable form. So you know the relation to find the transfer function, that is h of z, that is h of z is equal to h of 0 plus summation n is equal to 1 to n minus 1 by 2 h of n z power n plus z power minus n. This is equal to h of 0. So here we have already found the values for h of 0, h of 1, h of 2, h of 3, h of 4. So h of 0 is 0.75, and then h of 1 is minus 0.225 z power 1 plus z power minus 1, and then h of 2 value is minus 0.159 z power 2 plus z power minus 2. plus, that is minus 0.075 z power 3 plus z power minus 3, and h of 4 is 0 and h of 5 is plus 0.045 z power 5 plus z power minus 5. So we found the transfer function h of s, which is a non-realizable form. Next, step 6, that is a step 5, that is transfer function that is a realizable form and causal filter, that is h of z bar. So how to get this realizable form, that is z power minus n minus 1 by 2 into h of z, that is equal to n value is 11, so 11 minus 1 10 by 2 5, z power minus 5 into h of z. You just multiply the z power minus 5 by h of z, which gives the filter which is in realizable form, that is a transfer function, which is equal to 0.75 z power minus 5 minus 0.225 z power minus 4 plus z power minus 6 minus 0.159 z power minus 3 plus z power minus 7, then minus 0.075 z power minus 2 plus z power minus 8, then plus 0.045 z power 0, that is 5, that is z power 0 plus z power minus 10. So this is the transfer function. So from that realizable form, you have to arrive the new filter coefficients, that is h of 0. h of 0 is equal to, here z power 0, h of 0 is equal to 0.045. h of 1, say h of 1 is 0, you don't have the h of 1, 0. h of 2, h of 2 is minus 0.075. h of 3, h of 3, h of 3 is equal to minus 0.159. h of 4, h of 4 is minus 0.225. h of 5 is equal to 0.75. Okay, so in this way you have to find the new filter coefficient which is in realizable form for the causal filter. So this is about the step 5. Next, step 6. In step 6 you have to find the frequency response. Step 6 is frequency response, that is h of e power j omega. So you know the relation h of e power j omega is equal to a of 0 plus summation n is equal to 1 to n minus 1 by 2 a of n into cos omega n. a of 0 is equal to h of n minus 1 by 2. a of n is equal to 2 into h of n minus 1 by 2 minus n. So from this, first find the value for the filter coefficient a of 0, that is h of n minus 1 by 2. 11 minus 1, 10, 10 by 2, 5. So h of 5. So you know that we have already found the filter coefficients as, h of 0, that is h of, for a of 0, h of 5. So h of 5, it is 0.75. 0.75. Then A of n, that is A of n for A of 1 is equal to 2 into h of 5 minus 1. 5 minus 1 is 4. 2 into h of 4. That is h of 4 value is minus 0.225. So 2 into h of 4, that is a 0.225, the value is equal to minus 0.45. A of 2 is equal to 2 into h of 3, that is the 5 minus 2, 3, 2 into h of 3, 2 into 0.159, that is minus 0.318. A of 3 is equal to 2 into h of 2, and this value is h of 2 is equal to 0.075. This value is equal to minus 0.15. And A of 4 is equal to 2 into h of 1. H of 1 value is 0, is equal to 0. A of 5 is equal to 2 into h of 0. H of 0 is 0.045, and this value is equal to 0.09. Then we have found the filter coefficient. From this, the frequency response is equal to A of 0, 0.75 minus 0.45 cos omega minus 0.318 cos 2 omega minus 0.15 cos 3 omega. For n is equal to 4, it is 0. Then plus 0.09 cos 5 omega. 0.75, 0.45, and then cos omega minus 0.318 cos 2 omega minus 0.15 cos 3 omega plus 0.09 cos 5 omega. To find the frequency plot, to find the magnitude, that is a plot for different omega value, that is for different pi values, that is omega value ranges from 0 to pi. Take it from 0, 0.1 pi. For different pi value, you can find the h of u omega. So in this way, you have to design the FIR high pass filter. Okay, let's we compute a brief about what we discussed so far. That is, the question is to design a high pass FIR filter for the given frequency response. The step 1 is you have to draw the response from the given specification. That is, the frequency response is from minus pi by 4 to, that is the modulus value, plus or minus minus pi by 4, and then to pi by 4 to pi. From this, you have to find the desired response by applying the integral value. From this, find the desired response as sin n pi minus sin n pi by 4 by n pi. Next, step 2, you have to find the actual response. From the given samples, you have to find the actual response. N is equal to 1, n is equal to 0 to n minus 1 by 2, so that n is equal to 0, 1, 2, 3, 4, 5, and then substitute this value to find the actual response in the desired response. Apply the L'Hospital rule. Because 0 by 0 it is an undefined, so for different n values find the actual response value. Step 4, transfer function which is in the non-realizable form. The relation is h of 0 plus summation n is equal to 1 to n minus 1 by 2. H of n is z power n plus z power minus n. Substitute the value. Then realizable form, you just multiply the h of z value with the z power minus 5. From that, after converting this into realizable form, arrive the new filter coefficient. Okay, you just pick it from z power 0, z power 1, z power 2, z power 3, z power 4 and z power 5. Next, the last step is find the frequency response. So you know that relation h of e power j omega is equal to a naught plus summation n is equal to 1 to n minus 1 a of n cos omega n. For different n values, find the frequency response. That is, a of 0 is equal to h of n minus 1 by 2, a of n is equal to 2 into h of n minus 1 by 2 minus n. From this, the frequency response obtained is equal to 0.75 minus 0.45 cos omega minus 0.318 cos 2 omega minus 0.15 cos 3 omega plus 0.09 cos 5 omega. Thanks for listening. Let's have a small assignment for you. For this same problem, take the frequency response from pi by 2. Okay, take the frequency response from pi by 2 omega less than pi, that is 1, that is 0 otherwise. Okay, minus pi by 2 pi. So solve the answer for this question in the comment section. Thank you so much. Thanks for listening.